Thanks everyone for joining us. This is session 3 on labor markets. To kick us off, we have Lukas here to talk about the role of referrals in inequality, mobility, and inefficiency in labor markets.
Hi everyone. So my name is Lukas Bolte, and it's a real pleasure to be here and present joint work with Nicole, Immorlica, and Matt Jackson. And what we're looking at is how referrals matter in determining inequality, immobility, and inefficiency in labor markets. So let me jump straight into the model. We have a unit mass of long-lived firms who in each period hire exactly one short-lived worker. And there's a mass n greater than 1 of such potential workers for each period that is looking for jobs. Each of these workers, so worker I, comes with a productive value VI, that is the same across all firms that hire that worker. And this value VI is independent across workers and distributed according to some distribution F. The key ingredient to our model is the presence of referrals. So referrals, they matter empirically. There's a large literature that shows this. And essentially at all skill levels, you find that a large fraction of jobs are found through referrals. How do referrals enter our model? Well, firms can get a referral from one of their existing workers. In this case, the firm would perfectly see the value of the referred worker. So implicitly, we assume here that the referring worker, the current employee, knows something about the referred worker. Alternatively, the firm can hire from an anonymous pool that consists of workers who didn't have any friends who referred that worker or are otherwise thrown out of the labor market. In this case, the firm actually doesn't observe anything about the values of the workers in the pool, so it cannot condition its hiring decision on that value, and instead just gets the expected value of the pool. So we had some informational extreme where on the referral market, so when a firm looks at a referral, the firm knows perfectly the value. And when the firm hires from the pool, the firm doesn't know anything about the value of that worker. You don't need that extreme. What you do need is that there's more information if a worker is referred to the firm than if the firm tries to hire a worker from the anonymous pool, which is also very supported in empirically. In equilibrium then, firms are going to have a threshold hiring decision, meaning that they're going to hire workers who are referred to them if they clear some threshold, specifically if their value is above the expected value in the pool, which is itself an equilibrium object. So let me talk a little bit more about how the referrals work. So here I have 7 time T workers. 5 of them are employed, which is shown with the little office building behind them, and 2 of them are unemployed. In addition to the productive value that these workers give to their respective firms in time T, they also can refer workers. So imagine that each of these time T workers has exactly 1 friend in the next generation in time T plus 1 workers. Now, if a time T worker is employed, then that time T worker refers the friend in time T plus 1 to its current employer, to the firm that employs the time T worker. This is shown with this thick black arrow. Otherwise, if a worker isn't employed, then the friendship cannot result in a referral. So we have just, we show this with these dashed gray arrows. Then a time T plus 1 worker, if that time T plus 1 worker is referred to a firm, then that time T plus 1 worker has an additional chance of being hired because that firm might then hire that worker. So in this case here, we have 4 such workers who are referred to at least 1 firm and 1 worker who's even referred to multiple firms. The bottom line here is really that in addition to the productive value a worker gives to the firm, the worker can also refer a friend. Let's now shift gears and look at the firms and their hiring decisions. So imagine that there is a time T+1 worker, and that this time T+1 worker has two friends in time T. And both of these friends are employed. So that worker is referred to two firms. These two firms then perfectly observe the value of the time T+1 worker. Imagine that the value of this time T+1 worker is particularly high, VH. In this case, both firms will want to try to hire this worker, and only one of them will end up hiring this worker. They can only hire up to one. So the other one then has to enter the unanimous pool. It could also be the case that the time T+1 worker has a particularly low value. And in this case, none of the two firms that observe the value of that worker would want to try to hire this worker. And instead, they would all try to hire a worker from the unanimous pool, where also the time T+1 worker is heading to, since she did not get hired on the referral market. So the labor market really consists of these two parts. There's this referral market in which firms can look at the value of the workers that are referred to them and make a hiring decision contingent on that value. And this unanimous pool where all the leftover workers who weren't hired are present, and firms can try to hire them there, but only randomly and blindly. Also observe the presence of a Lemons effect. So the referred worker in time T+1 was only hired on the referral market when her value was high and not hired when her value was low. So the unanimous pool is going to consist of workers who either had no friends, in which case they're still unspoiled, or they had friends, but then were deemed to be not good enough on the referral market. So they then have particularly low value, the lemons. So the value in the unanimous pool will be below the average, the unconditional average value of all workers. In equilibrium, then, this is going to adjust so that the value in the pool is going to be consistent with the hiring decisions on the referral market. What can you do with this model? Well, so we look at inequality, and for the purpose of this talk, I'm going to look at inequality across two groups, and immobility and inefficiencies. So to that end, let me introduce some blue and green workers. Here we have for green workers, two of each are employed, and they refer only workers of the same group. You might have an issue with this strong form of homophily, but other than that, there doesn't seem to be a lot going wrong in terms of inequality. You have two of each who receive a referral. It seems quite equal. But now imagine the situation where all the initial employment is concentrated among one group. While keeping the friendship arrows all the same, we switch from some gray dash arrows to black arrows and vice versa. And now you have that only blue workers in time T+1 receive referrals and none of the green workers. This is because of this strong homophily. If you abstract from the type of worker and look at the more aggregate time T+1 workers, you also see that there are now only 3 workers who receive at least one referral. The reason is that now all these referrals are concentrated among a smaller group of workers. And there's now one worker who actually receives multiple referrals, which wasn't the case before either. So there's a concentration of referrals that goes along if you have concentrated initial employment. What are the effects of these? Well, so imagine that we start off with blues being more employed than these greens. Then the employment of blues at the end of the period, so at T+1, will also be higher than that of greens. The reason is that they receive more referrals, and referrals provide additional opportunities to be hired. Hence, they will have higher employment at the end of the period. their wages will also be higher. And this is not only the case because they have more workers who receive a wage because they're employed, but also because the wage is determined by relative bargaining weights of workers and firms. And when there are more than one firm competing for the same worker, as can be the case only on the referral market, this drives up wages. And this is predominantly the case for blue workers. Interestingly, you'll also have the case that if you look at the employed blue workers, you'll find that their average value is higher than that of employed green workers. The reason is that these workers come from the referral market where they have been filtered and sort of handpicked. So they have a higher average value compared to the green workers that come from this random pool. And if you're naive as an employer, you might conclude that blues are better than greens, which isn't the case in our model. The flip side of this is that greens in the pool actually have a higher value than blues in the pool. So the disadvantaged group in the pool has a higher value than the advantaged group in the pool. And the reason is that there are more lemons of the blue of the advantaged group in the pool, since the greens they could never be picked out, and the blues only the ones who didn't clear the bar on the referral market are entering the pool. So referrals then provide a link between inequality, mobility, and productivity as well. So we have that if you start off with this unequal employment, through referrals you get inequality, through referrals you get immobility, because you end up with this employment inequality, so you're essentially back at where you started. You also have an effect on productivity. Remember that I said that if you just look at the T+1 workers, forget about the groups, you find that fewer workers were vetted. In the case, we had the employment concentrated among a small group. And the reason was that now all the referrals were concentrated among a small group. Essentially, you'd stop looking at the whole society and you do less vetting. That reduces the efficiency of the search process and harms the sorting, and thus decreases productivity. So all three, inequality, immobility, and productivity, are intertwined. So you might care about this referrals and everything that I've been talking about, not only because of fairness in outcomes and opportunities, which might be good enough reasons already, but also just because of efficiency. So what can you do about this? One thing that you can do about this is you can try to increase the green employment in a particular period by some small amount. Imagine, for example, that you tax the hiring of blues, you subsidize the hiring of greens, you set quotas, you set caps, and so forth. What happens then is that a small increase in current green employment is going to increase green employment in every single future period. And the reason is because of this rippling forward effect of employment through referrals. It also increases overall productivity, because now in every period, since you have more equal employment, you're going to have that the referrals are more spread out, implies better vetting, which then implies higher productivity. So here are just some graphs that sort of show this in a numerical example where we increase in time zero the employment of green. And you can see that with the affirmative action, the orange one, it lies above the without affirmative action in all the future periods as well. So I'm plotting the employment of green against time. Here I'm plotting total production. So you have a loss in total production because of the way that this is implemented, but then an increase in the subsequent periods. So let me just conclude on the affirmative action aspect here. Affirmative action in this model reduces inequality, reduces immobility, as well as productivity in every single future period. So there's a certain appeal to it. And that's all I have for today. Thank you very much for your time.